How does the glycocalyx relate to chronic disease? Find out on this next episode of Digest This.
Welcome to Digest This, the show that helps you revolutionize your digestive health. Here are your hosts, Dr. Liz Cruz and Tina Nunziato.
Hello, and welcome to Digest This. I'm Dr. Liz Cruz, and I've got Tina Nunziato sitting right here next to me. If you're watching us, we are so excited that you're here. If you're one of our regular listeners, we love you. We are so appreciative that you continue to be on this journey with us. If you're a first-time listener, welcome, and we hope that you will continue to join us. We have over 500 episodes on our podcast. We've been podcasting for over 10 years, and so a lot of great information. Today, we are very excited because we have a guest that actually is not a guest anymore. She's part of our family because she's been on our show already, apparently 2 years ago. I can't believe it's been 2 years. Her name is Martha Carlin, and Martha is on with us today, but she podcasted with us back in 2024. And
Time flies.
Time
right,
does
Martha?
fly. Yeah, time does fly. So welcome, Martha. We're so excited to have you back on our show.
Yeah, it's nice to see you again.
It is. It's great to see you. Let me just share with you a little bit about Martha. So first of all, she did 2 episodes with us back in 2024. So one of the episodes was on food supply and how it affects our microbiome. And the other episode was on negative effects of endurance training. So you can go back into 2024 and find those episodes.
Those were in June and July.
June and
of
July. Okay,
2024,
perfect.
If you're looking for.
So Martha recently released a book. It just went out earlier this year. It's called Connected: Love, Loss, and the Unseen Forces Behind Chronic Disease. Martha's husband was diagnosed with Parkinson's disease when he was 44 years old, and that catapulted Martha on a journey that led her into very deep research, just trying to discover the root cause of chronic disease. And Martha has published a lot. She's got a lot of peer review articles out there. And she really has dived into a world of discovery, and we were very intrigued and amazed at everything that she's done the last time we podcasted with her. Now she's released this book, which, by the way, you can find it on Amazon, Barnes & Noble, pretty much on any book site, right, Martha?
Yes.
Okay. All right. So she just launched this book. We've been very fascinated by one of her topics. It's called the Glycocalyx connection. I told Martha that the last time I heard that term was actually in medical school. So I'm very fascinated. I think that if it's not already mainstream, it's going to become mainstream. We've been hearing a lot about the microbiome, so it's time to bring something new into the mainstream. And so I told Martha that we want to really have her talk about this today. I think it's fascinating, and I am excited to hear what she has to say about the glycocalyx. So,
Yes.
Martha?
So, Martha, first, before we get into the glycocalyx, just tell us, what have you been doing for the last 2 years since we saw you?
Well, for the last 2 years has been quite busy. Sadly, I did lose my husband, John. Not long after our July episode, John had a pulmonary embolism in September of 2024.
Oh my goodness.
And
That's
so,
hard.
for 6 months after that, I was really pretty shaken, but also re-energized in trying to understand the connection between a pulmonary embolism and Parkinson's, where, we look at all these diseases like they're separate things and you go to separate doctors. But really, if I go all the way back to my TED Talk in 2016, I talked about Parkinson's being the collapse of the body's ecosystem. So one of the things that I was really working on, I connected with a scientist in Australia named Barry Ninham in 2002, and he's arguably the world's most famous colloid and surface chemist, which people are like, what's that? Well, our cells are just a big assembly of surfaces and colloids, things that clump together. And through learning from him and taking his research with what I knew about Parkinson's over the last 2 years, really, we're working on a paper that explains the physical chemistry of Parkinson's through the lens, and the paper is called Gut, Brain, and Glycocalyx, A Portrait of Parkinson's. And we were able to take the microbiome and what is happening physically, in the battle in the gut and the chemistry of the body and what is known of these different pieces and put the picture together, which this glycocalyx is a big piece of that puzzle.
Hmm. That's amazing. So sorry about your husband.
Yeah.
Thank you.
And it's amazing what you've been able to do with everything that's happened in your life and hopefully the positive that you're going to bring to the world with all of this. So, I mean, I guess to kick off that conversation, can you tell everyone what is a glycocalyx?
So, I mean, it's interesting that Dr. Liz heard about it in medical school, so that's good. Typically, the way it's been taught is it's just this fuzzy layer around a cell.
Mhm.
There's a researcher, Dr. Hans Vink, who is the world's pioneer in studying the endothelial surface layer glycocalyx. So it's this complex where every cell in the body has this fuzzy layer around it. So the cell membrane is about 2 to 3 nanometers thick, so tiny, tiny, tiny. And then the layer just outside that is the glycocalyx, and that's about 50 nanometers thick. And that's primarily made of hyaluronic acid, which holds a lot of water, so it keeps things hydrated. And then the endothelial surface layer is these sulfated polymers, like almost like seaweed, that is our little fingers that are negatively charged, that come out from that glycocalyx. And it's kind of a system of intelligence and sorting, I'll say. It shapeshifts and morphs and allows things like oxygen and nitrogen to get in, carbon dioxide to get out from metabolism, nutrients to get in, and waste to get out, but it lines every surface of our body. So it's lining our blood vessels. So the work that Dr. Vink did was actually taking images. He developed the techniques to show blood flowing through a blood vessel where you could see this thin layer and the little hairs moving with the blood, the pressure of the blood as it was moving back. So if you think about like the ocean and seaweed moving with that shear stress of the ocean, that's the same thing sort of going on in the blood. But it also it's the lining of our gut. It's the lining of our brain. Everything is coated with this fuzzy layer. And there are a lot of things that can damage it. And then there are also one of Dr. Ninham's areas of expertise is something called specific ion effects, which just means different electrolytes have different effects on this, well, generally in chemistry, but on the glycocalyx specifically. And one of the ones that we looked at very closely in Parkinson's is the relationship between sodium and potassium. So, our blood is supposed to be the salt concentration of the ocean, roughly. And it's 0.15 to 1.17 molar. And when it goes above or below that, it will change the, that glycocalyx structure. And then potassium, which is supposed to be inside the cell, not outside the cell where this fuzzy layer is. If too much potassium gets outside the cell, it stretches those little seaweed-like hairs out and they get very stiff. And then it becomes hard for anything to get in or out. And that was part of the foundational discussion in our Parkinson's paper. But it really ties to, leaky gut, insulin sensitivity, any of these things. They're all sort of traveling through those layers to get in and out of the cell.
Okay. So
Wow.
what happens in the case of Parkinson's then with the glycocalyx?
So in our paper, what we discuss is there's a battle going on in the gut between the good and bad bacteria. And there's now, I think, over 2,500 papers on Parkinson's and the microbiome. They don't all agree exactly on the species, but as you can see, some structural commonalities, and there are a number of bacteria that produce an enzyme called urease.
Uh-huh.
And that enzyme is very damaging to other bacteria. And what will happen is then it kills the other bacteria, spills them, their contents spill out. So you end up with potassium.
Uh-huh.
Uh, and that excess potassium is then stretching out that glycocalyx, the hair structure, but it is also, you're supposed to have a high salt concentration outside the cell. And that salt concentration is how signal gets propagated through the
Mhm.
body. And like you might know this from just doing a science experiment in school where, you put salt water and you made a little battery. And
Mhm.
so what happens when you get that spilling of potassium, it short circuits the battery because you don't have enough of the salt concentration.
Hmm. That is fascinating. It's amazing all the stuff that's going on in our bodies, right? And we're just going about our life just like
Nothing.
so when we eat, like, let's say we eat a very high sugar meal or highly processed meal, like, is the glycocalyx just then constantly in a state of getting a little bit of pull here and stiffness and damage, and then you can repair it? Like, it'll then repair like within 24 hours if you eat like a high plant base, a lot of greens. I mean, I'm just trying to figure out the dynamic there of the glycocalyx.
Yeah, I would say it's very adaptable,
Mm-hmm.
and it can recover pretty quickly. But in today's world, we're constantly assaulting it with processed and packaged foods, a lot of these preservatives, emulsifiers, cleaning products, a lot of our cleaning products, which I have been writing some lately about quaternary ammonium compounds, and we have a paper coming out on that and how that damages the cell membrane and the glycocalyx.
Actually, so wait, pause on that. The cleaning products. I mean, so let's talk just a minute about that because everybody does cleaning in their house and they've got these products. I mean, are there any specific products? And is it just then in inhaling the vapors of these products that it gets into the system and affects the glycocalyx?
Well, it's more than just the vapors. What are called quaternary ammonium compounds are things like if you looked on your cleaner, if it said benzyl alkonium chloride, or throat lozenges and mouthwashes also will maybe have cetyl pyridinium chloride, things that have chloride or bromide, often like hair conditioners that make your hair feel soft. There's also something called DDAC, which is a mouthful. What I can do is I have a consumer guide PDF that people can download because this was really an eye opener for me because they accumulate. So,
Mhm.
yes, you know, we can adapt, we can repair. I mean, that's what's so amazing about the human body. But as we are constantly continuing to have things that disrupt it,
Mhm.
we can't. I mean, it just becomes harder and harder to repair. And it can repair, but these cleaning compounds are cumulative.
Mm.
And, if we look back from 2020, and there's more research coming out on this in publications about the rapid increase in the amount of hand sanitizers and cleaning things during COVID, that
Mhm.
it's leveled off a little bit, but not as much as it needs to because people just aren't aware of how damaging these are. And they can take, 9 months or longer based on Dr. Ninham's research to
Wow.
leave the body. So if you're getting more exposure every single day, then it's just accumulating and building up. And if you look at just general ecosystem science,
Mhm.
you know, typically what you'll see, and I like to use coral reefs as an example. A coral reef, can get some damage and repair and get some damage and repair and do okay. And then all of a sudden some tiny little thing happens and the whole thing collapses. So you can have this kind of straw that breaks the camel's back, but it's just you can't just take that one straw off and the
Mhm.
camel gets up.
Huh.
So, it really is important that we think about we are what we eat, we are what we expose ourselves to, and that
Yeah.
we just be mindful of what we're putting in and on our body and how that might affect the surfaces inside.
Hmm.
Yeah, we talk a lot about just don't forget like the shampoos that you're using and the perfumes and the lotions, the creams. People are putting so much stuff on for different reasons. They don't even think that anything that in that product could be damaging their cells in any way.
Well, I haven't looked at this in terms of glycocalyx, but just in sensory issues, all of these artificial scents and
Mm.
artificial flavors, it's a
Right.
signal to the body that something is coming, a
Uh-huh.
nutrient that it might be able to use. So when you're smelling artificial scents and then the actual thing doesn't come, or you're tasting an artificial flavor and what the whole
Thanks.
computer system of the body is expecting doesn't come, then there's sort of this staticky
Mm.
confusion about, okay, well, these are signals. I'm supposed to be able to interpret them, and that's not what came.
Right.
Interesting.
Wow, fascinating. Let's say that the exposure to all these cleaners, like let's just say we decided not to use any of those chemicals and we're not being exposed to that stuff. So you said that it could take up to 9 months for these things to get out of our body. And are you having to use some sort of a binder to try to get them out, or is it just over time they will release
Well,
as long as you're feeding your body good food?
that is really an important question that I'm not sure has completely been answered by the science, because one of the questions I had for Dr. Ninham, of course, the body is constantly recycling cells through a
Mhm.
process called autophagy,
Mhm.
self-eating. It eats up and takes things apart and reuses the raw materials. But if you have raw materials that you didn't want in there in the first place, like what happens to those? And I
Right.
don't think that the actual research to show what happens to those in that cleanup process actually do they get eliminated, through waste in the body or not? And that really hasn't been answered yet.
Okay. Yeah.
So, in the case of Parkinson's, what happens with the glycocalyx exactly? Does it disintegrate? What have you found in your research that you related the glycocalyx to Parkinson's?
So, our work, I would say, is theoretical to some extent because specific imaging of a Parkinson's glycocalyx has not been done. It's been done in mostly in the cardiovascular and the kidney side of things.
Mhm.
But from Dr. Ninham's work in layering on, the pieces from Dr. Vink's work and the microbiome connections I had from the data that we have in our Parkinson's study and the other published Parkinson's research, and then the chemistry of what is known from individual papers, we were able to put the puzzle together to propose what we believe is happening. We don't have imagery or anything like that to show that yet. We'd love
Mhm.
to have some people come on board and start to do that kind of work, but the two main things are the stiffening of this glycocalyx that is affecting whether or not nutrients can get in and waste can get out. So
Okay.
that's a major problem. We know in Parkinson's, the waste is not clearing the brain and the lymphatic system is not working properly. And this whole sodium potassium, we did find published kind of a larger population level where there was a difference in the potassium in people with Parkinson's, so slightly higher. And you have to measure it. The problem most of the time in measuring potassium is it's measured in the serum, and you need to measure it inside the cell because it's supposed to be inside the cell.
Mhm.
And the body, and you probably learned this in medical school, the body does a really good job of maintaining sodium and potassium balance
Mhm. Mhm.
because it's got to do that in the
Yeah.
blood to keep you alive. So looking at it there where it's constantly battling that equilibrium is not the place to look at it. You've actually got to look inside a cell. And I think this goes to, leaky gut, leaky membranes, leaky everything.
Mhm.
If you're not holding your structures together, which again goes back to that glycocalyx, if the structures aren't strong, then, you know, you've got a problem.
Right.
So, and that, if that's affecting signal propagation,
Yes.
which is what we see in Parkinson's. And in my book, I have a chapter on vision that ties a bit. So the eye is actually one of the organs in the body that is made of the most sulfated polymers. It's one of the earliest developmental parts of the embryo. I mean, a significant amount of the eye is glycocalyx, or those sulfated polymers.
Mm. Very
Fascinating.
interesting.
This is so awesome. Well, sounds like there's a lot of great research being done. And it's so cool that you're in the midst of all that.
Well, I mean, I'm still searching for answers. I'm searching for
Sure.
answers for John and for all of the people that we developed relationships with over the years and that I've just come to know through the Parkinson's community. But, another interesting piece of the puzzle that came into play after John passed away. So he had this pulmonary embolism, and those are also connected to, vascular damage in the glycocalyx of the vasculature.
Mhm.
And there's a exercise, and it's called Parkinson's Point. It's a physical therapy exercise and education that John was involved in getting set up in Denver, Colorado. And I had a meeting there in January with the executive director, and she said that if she hadn't known what happened to John, maybe she wouldn't have been so alert to this. But she had 5 other Parkinson's patients in her facility who passed away from the same thing, a pulmonary embolism.
Hmm.
And, Parkinson's, you don't ever hear anybody talk about cardiovascular and
Yes.
Parkinson's together. If you're having a cardiovascular problem, you're over here at the cardiovascular doctor and you're over here at the neurologist, and they're not speaking to each other.
Mhm.
And, we're a whole system. It's all interconnected. And I think we could prevent a lot of things and do a lot more for people if we understood them as a whole system. And it was also really interesting to me over the years in neurology. They don't do blood work, and knowing what I know about the gut microbiome and the metabolic issues involved in what's going on in the gut related to energy production and everything else. If we had records of all these Parkinson's people over the years with blood work, we would have a much richer understanding, perhaps, of the metabolic connection. Yeah.
We would be much further along, I feel
Yeah.
like, for sure in this research. Yeah, that's a really good
Yeah.
point.
Didn't even think about that though, because as a GI, we order a ton of blood work, checking for anemia, celiac disease. We want to know what the liver looks like. And I never even thought about that. When you said that, I was like, yeah, actually, why would a neurologist order blood work unless they're acting as primary and wanting to just check their electrolytes and things like that? But so that's a great point.
Well, and also neurotransmitters are made in the gut.
Yeah,
I
yeah.
mean, they probably weren't taught that in medical school because that's a fairly, in the last decade, really more discussion around that. But,
Right, right.
80% of your serotonin is made in the gut. Gut bacteria make dopamine. Some
Yes,
gut
yes.
bacteria eat dopamine. I mean,
Mhm.
so there's
Oh,
a
yeah.
whole, there's a whole suite of things you could really be looking at clinically to at least
Absolutely.
try to connect a dot.
Yeah, absolutely. Even, as far as women's health and estrogen and all that. I mean, there is so much.
Yeah, I feel like when medicine separated out into specialties and became so compartmentalized, we really, like to your point, we lost the value of the whole body. I mean, I
Absolutely.
know you can see why medicine did it. This requires this specialty. This where there's so much studying to do with the brain. There's so much studying to do with the heart. But it really did that compartmentalization really did a disservice to medicine and healing the whole body.
Yeah,
So
very
it's
true.
incredible.
Yeah, and it's true to what you said about cardiovascular issues and Parkinson's. I mean, if somebody back in my day of practicing internal medicine and they're like, what about this cardiac issue? And my husband's having Parkinson's. I'm like, yeah, that's not related. You're going to have to go to the cardiologist. I mean, yeah, you would not put that together.
Well, and there's increasing evidence in Alzheimer's
Mm-hmm.
that, part of the issue is with the cardiovascular system and vascular restriction in this blood flow to the brain.
Interesting.
Because if you're not able to vasodilate and get good blood supply to the brain, then, that's not going to be good.
Right.
Yeah.
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 Fascinating. Wow. Well, gosh, this is awesome. I mean, is there anything else that you want to tell us, tell our audience? I mean, we've covered a lot and this is such great information.
Well, I talked to you a bit about my book. So I have a new book out, and that tells the story of the 24 years of looking for answers for John. It's in part, it's my love story or our love story, but it's also the scientific journey of kind of putting some of these pieces together and the scientists who helped me do it. And it's also a bit of an indictment on the way we practice science and medicine
Sure.
in this. Well, it's maybe more than a bit of an
Yeah.
indictment, but
I
it's
bet.
basically calling out the fact that we have moved into this very reductionist way of thinking and how
Mhm.
much damage it has done in terms of not being able to see the big picture and humans as a whole. There's also another aspect of it, and I learned this from working on a docu-series with a woman who has Parkinson's and is involved in the Resolve Parkinson's Foundation. We have a docu-series called Voices of Parkinson's that we're working on the editing now, and we interviewed 35 people with Parkinson's, and one of the themes that came out of that was a connection to stress, either chronic stress over a long time or these acute stress events, loss of a job, loss of a parent, loss of a child, a major accident, different events like that that were triggering events that
Mhm.
elevated stress load and changed the trajectory. And
Mm.
almost without, I would say 99% of the people that we talked to, there was something like that. And that's also not talked about. And then, of course, if you give somebody a Parkinson's diagnosis, I mean, that's a pretty stressful triggering event right there.
Sure.
So I talk a bit about that. So there's a number of things in the book that I think will make people think a little bit, not just about Parkinson's, but
Mhm.
about any chronic condition and what are maybe some of the pieces that they were missing. And I do revisit like our discussion on endurance exercise,
Hmm.
and go into a bit more detail because I ended up further down that rabbit hole with another young woman who has Parkinson's who runs marathons and loves to exercise. And I've been talking to her about how damaging it is. But it's kind of and it's an addiction.
Yeah. Yeah.
It's an addiction. There's a chemical kind of relationship there too of that runner's high, but it's also very damaging to the glycocalyx. And, I don't think I had really fully grasped the glycocalyx when we talked about it, but I do talk about that in the book more. And that exercise and movement is really important, but not excess exercise and the
Mhm.
pounding type things you do in, say, doing a marathon.
Mhm. Interesting.
Yeah, that's
Wow.
awesome.
Well, we'll definitely put a link to the books.
Okay, I will send you that, and I will also send you our consumer guide for the cleaning products, so you can see
Yes.
that
Yeah,
as well.
that would be
Yeah.
great. Wow, that's awesome. Well, you got to get out there and get this book. And again, the book is called Connected: Love, Loss, and the Unseen Forces Behind Chronic Disease. I think everybody needs to get this book. And again, you can find it on Amazon, Barnes& and Noble. It sounds like you can pretty much find it anywhere. Well, Martha, thank you so much for joining us and for sharing all of this with us. This is fascinating and very educational. And thank you for everything that you're doing in this space. It's so great. I mean, we're so sorry about John, but the fact that you are continuing and pushing forward to try to help so many others out there says a lot. And so thank you so much.
Well, thanks for having me again, and thanks for everything you do to
Oh,
help
thank you.
people understand these things because there's so much we can do to have a better outcome in our health, and education is a big part of that.
Yep, absolutely. Well, thank you so much for joining us. And if you have not connected with us, please connect with us. There's so many ways you can connect with us. Number one, you're watching this podcast. If you haven't rated us, you can rate us. Give us a 5. It'll help other people just like you to find us faster. If you haven't subscribed, please subscribe so that you never miss an episode. You can also go on our website, drlizcruz.com. You can schedule a free 30-minute wellness consult. There's a button on the homepage. It's a magenta color. follow button. You can click that and it's free. You could do it anywhere because it's done over the phone. You can subscribe for our newsletter. We send that out every 2 weeks. So all sorts of ways to connect with us. You can also reach out to us on our website. We have our contact information, our number, our email. It's all out there. So please reach out to us, connect with us. We're so grateful that you have joined us on this podcast, and we'll catch you on the next one.
Thank you for joining Dr. Liz Cruz and Tina Nunziato. To learn more about their revolutionary products and services, go online to www.drlizcruz.com.